Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of derivatives. So as per the problem, for the function, check for discontinuities and make a rough sketch of the curve. Now the given function is a rational function. So a rational function can have a discontinuity in the form of whole or vertical asymptote. Now in this rational function, there is no factor that's common to the numerator and the denominator. So that means this rational function has no whole. So that's our first conclusion. Now we can check for vertical asymptotes by setting the denominator expression equal to 0. So we do x plus 2 square equals 0, and now we have to isolate x, so we can square root both sides. So on the left side, the square root on the square get cancelled out, so we get x plus 2 equals 0, and now we can isolate x by subtracting 2 from both sides, so we get x equals negative 2. So this is the vertical asymptote in this rational function. Now we have to figure out the behavior of the function on the left and the right hand side of this vertical asymptote. So for that, we'll apply the limit to this function on the left hand and the right hand side of this vertical asymptote x equals negative 2. So let's start with the left side. So limit x approaches negative 2 from the left side, and the function is 5 equals x plus 2 squared. So now for this limit, we'll have to use an x value to the left side of negative 2. So one example can be negative 2.1. So if we sub in x as negative 2.1, so the denominator will always be positive because of the square on the expression x plus 2, and the numerator is just a number, so that is also positive. So for x equals negative 2.1, so we'll end up with the expression that's positive over positive, which will give us an overall positive value for this limit. Now we can evaluate the limit on the right hand side of this vertical asymptote. So limit x approaches negative 2 from the right side. So for the function 5 over x plus 2 squared. So for this limit, we can use a test value negative 1.9 because it is to the right side of negative 2 on the number line. So for x equals negative 1.9, so the numerator will always be positive here because it's just a positive number, and the denominator will also be positive because of the square on x plus 2. So again, we'll end up with the overall positive value. So for the vertical asymptote, the end behavior will be, so as x approaches negative 2 from the left side, y approaches positive infinity, and as x approaches negative 2 from the right side, y approaches positive infinity. Now we can check for the intercepts. So let's start with x-intercept. So we'll sub in the function value as 0 in the given function and then solve for x. So we get 0 equals 5 over x plus 2 square. Now here there is no x in the numerator, So if we cross multiply the denominator, we get 0 equals 5. So that means there is no x-intercept for the rational function. Now we can analyze the y-intercept. So for the y-intercept, we'll sub in x as 0. So f at 0 equals, so 5 over 0 plus 2 square, which is equal to 5 over 2 square, which is equal to 5 over 4. So the y-intercept is 0, comma 5 over 4. Now we can find the critical points for this function. So for that, we'll have to find the derivative of this function, because critical points are points at which the derivative is equal to 0 or undefined. So now to find the derivative, we should move the denominator expression to the numerator, because that will make it easy to find the derivative. So we can start by changing the given function equation. So we can rewrite this as f at x equals 5 times x plus 2 exponent -2. Now we can find the derivative of this function using the chain rule. So in this function, there is an inner function x plus 2, and then the outer function is the exponential function with the exponent -2. So prime of f at x. Now 5 is the coefficient of this term, so it will stay as it is, times the derivative of the outer function. So we'll use the power rule. So the -2 exponent will move to the front, and we'll subtract 1 from -2 times the derivative of the inner function, which is x plus 2. So the derivative will be 1 plus 0. Now we can simplify this expression. So prime of f at x equals -10 times x plus 2 exponent -3. So 1 plus 0 is just 1, and multiplication by 1 doesn't change anything. Now we can move the x plus 2 to the denominator to make the exponent positive. So -10 over x plus 2. Now we can set the derivative equal to 0 and solve for x. So we get 0 equals -10 over x plus 2 cube. Now we cross multiply the denominator. So 0 times x plus 2 cube will just be 0. So we get 0 equals -10. So that means there are no critical points for prime of f at x equals 0. Now we can find the critical points at which the prime of f at x is undefined. Now the prime of f at x is a rational function, so we'll set the denominator equal to 0, because the rational function will become undefined if the denominator is equal to 0. So now we can solve for x by subtracting 2 from both sides. So the 2's on the left side get cancelled out. So we get x equals -2. Now we got this x equals -2 as our vertical asymptote. So we don't need to analyze this any further. And we have also found out the end behavior around the vertical asymptote. Now the next step is to find the horizontal asymptote for this rational function. So now in this rational function there is no x term in the numerator, so we'll just apply the limit x approaches infinity to find the equation of the horizontal asymptote. So we'll do limit x approaches infinity and then 5 over x plus 2 squared. Now we'll apply the limit, so we get 5 over infinity plus 2 squared. Now in the denominator, infinity plus 2 is infinity and square root of infinity is infinity. So we get 5 over infinity, which is equal to just 5 times 0, which is equal to 0. Because 1 over infinity is equal to 0. So for this rational function, the horizontal asymptote is at y equals 0. Now we can find out whether the function approaches this horizontal asymptote from the top or from the bottom. So for that, we'll evaluate the limit for this rational function for a big negative number and a big positive number. So let's start with the left side of the x-axis. So limit x approaches negative 100, so for 5 over x plus 2 squared. So now we can apply the limit. So we get 5 over negative 100 plus 2 squared. So because of the square on the expression in the denominator, we'll end up with a 5 and a positive value. So that will be square of negative 98. And this will give us a result which is greater than 0, because square of negative 98 is a positive value and 5 over that positive result will be a positive value, and that's greater than 0. So here we are doing the check for the reference value 0 because that's where the horizontal asymptote is. So that means on the left side the curve approaches asymptote from above. Now we can do the check on the right side of the x-axis. So we'll use the limit x approaches positive 100, and for the function 5 over x plus 2 squared. Now we can apply the limit. So we get 5 over 100 plus 2 squared. So now we end up with 5 in the numerator and 102 squared in the denominator, and the value of this fraction will be greater than 0. So that means on the right side of the x-axis, a curve approaches the horizontal asymptote from above. So now we are done with our analysis for this function, and now we can use all of these results to make a rough sketch of this curve. So let's start with the grid. Now the first thing we found is the vertical asymptote. So let's assume Negative 2 is here. So this can be our vertical asymptote. And then we found the end behavior around the vertical asymptote, that as x approaches negative 2 from the left side, y approaches positive infinity. So we can show that end behavior like this. And on the other side of the vertical asymptote, so it's the same end behavior, y approaches positive infinity. Now we can show the intercept. So there is no x-intercept and the y-intercept is at 0, 5 over 4. So let's assume it's over here, 5 over 4. And then we found the critical point, but there are no critical points at which the derivative is equal to 0. And then we found the horizontal asymptote, which is at y equals 0, which is the x-axis. And then as per the end behavior, the curve approaches the horizontal asymptote from above, both on the left and the right side. So now we can join these end behaviors to get the sketch of the curve. So on the left side, so we can just connect these end behaviors like this. And on the right side, we can join the end behaviors through the y-intercept. So this can be the rough sketch of the function based on the key features that we found for this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.